Hello, Bob. Hi, how are you?
I'm doing well. How are you this morning?
I am
This
doing,
morning in the US.
yeah, it's night time in Malaysia. So
Uh,
pleased to have you guys. I hope it's not too early for you guys. But this session, I'm really looking forward to this session because when we had this, our product, our podcast, I think a couple of months back, when you introduce your product, and it's one of a game changer, I would say. It's a interoperability problem statement product, right? So I'm really looking
yes.
forward to see this because I know a lot of people who is struggling. Actually, myself is struggling because I'm also a data solution architect. This product can go and do wonders for especially for data analysts, data stewards, and all those people, right? So again, welcome to our podcast. Let's talk about data, and floor is all yours, Bob.
Well, thank you. And thank you for having me and thank you for all the people that have joined us and signed up to look at this recording. My name's Bob Mack. As an introduction for people who don't know me, I've been in IT for about 40 years now. It's tough to believe it's gone so quickly. But I worked for many of the larger companies in the world. In fact, I worked for eight of the Fortune 100 companies over my career. So I'm used to these complex environments where people are trying to move data around and do ETL and build data warehouses and such. I also am the owner of 11 US issued patents on data design, data architecture design, and implementation. So that's my background. So to start, I have this slide that depicts a graphic that depicts the current state of data, right? So we have a sphere. Each sphere is a data system. It's isolated from the other data systems, right? The color of the spheres indicates the disparity of the data set. So each data set has its own representation of products and customers and et cetera, et cetera. And this is part of the problem. There's no data integrity enforced between data sets, and that makes the data architecture very fragmented and disjointed. Um, there's a lot of redundant data, and the data is poor quality. So therefore, it's not really appropriate for AI and ML, which people are trying to get to at this point. And we also found a recent survey that 75% of operational managers don't trust their data that they're seeing from their decision support systems, which is an unbelievably high number. So this I call actually a corrupted data architecture. So uh, for an analogy, when you populate a database and you turn off the referential integrity constraints, you get a database that's pretty much useless because there's no consistency across tables. When you populate a data architecture with data sets that do not have data integrity and force between them, you get the same sort of thing. You get this inconsistency across these data sets, and you can't join across the data sets. You can't look at data from different data sets at the same time. So this is what we're trying to fix. This is the big problem we're trying to fix with data compatibility. And I added a slide here. Please don't read this. This is just showing you the data integration complexity. It's layered architecture that follows. So you have these disjointed data sets that you're trying to integrate, and we're moving data and we're transforming data, and you all know what's involved in that. It's a very complex and tedious thing, and companies are spending a fortune on this. And just as a heads up, we don't do any of this with our architecture, right? So we take a different method. It's compatible with this. So we're not saying you got to throw all this out, but we take a different approach. So here's our approach to it. This is a compatible data foundation, right? So we encapsulate each data set with what we call our data compatibility standards. Now, we do this non-invasively. We don't actually change any of the existing data, so the data remains unaltered, but we encapsulate it with a wrapper so that we can set up communications between data sets by enforcing data integrity. So two things that are different: the encapsulation of the data, which is the modularization of the data set, and then enforcing data integrity between the data sets. And when we do that, we find out that we end up with a modular data fabric. Now, the data fabric is kind of interesting because you can take a brand new data set, modularize it, plug it into the fabric, and it interacts with or interfaces with all the other existing data sets. There's no software involved. So you can take one out. It doesn't impact anything else because they're modular. So this is a very object-oriented approach to data administration. So let's see. The motivation for doing this is now you can see all your data, in one place. In other words, with the incompatible data sets, you can only look at one data set at a time because there's no way to join across data sets. Here we can join across all the data sets, right? So you can see all your data. You can resolve issues, right? So you can find issues, resolve issues, things that you can't do with the older approach. And then the other thing that's interesting, we can also justify results. So when we get insights from this data, we can always go back to the source and justify what happens because we have the original source, and everything built beyond that is related to the original source. So there's no data lineage that you have to worry about. It's all straightforward. So we're going to start by talking about the difference between disparate data and compatible data. So I have this example. We have three databases, right? Database 1, database 2, database 3. The tables are all from, these are all address-related tables. So it's the master data domain is address. And what happens, we find that when we go to do a data warehouse project or whatever, we have the disparity between the table names, the column names, the content, the primary keys, right? So we found out from our experimentation that when we want to make data sets interoperable, it's the data set context that's very important to this. It's the important factor we have to control. So I listed these on the top right-hand corner of the slide. So the data set context is the shell of master data that encapsulates every data set, all right? So it's the who, what, where, when of the data sets, the master data. It's people, places, things, and time. So in this example, we're looking at address, which is part of that data set context. And we see the inconsistencies across data sets. So this is what we currently have. And what we're proposing is that we use compatible data set context, which is this example, right? So we have the same three database tables. We have consistent data table names, consistent column names, and the content is also consistent, especially the primary keys, right? So just to look at the difference again, this is what we currently have, right? And this is what we transform into. Now, to get to this, we use a third-party address validator, right? So we take the original addresses, send them off to our address validator. They do the matches, send matches back to us. We populate it into the standard structure, and you're done. You just have to relate the standard back to the original, right? So this is what we add to the data set. We don't change the original data set. So because we did this now, we have something new. We have In the data modeling, we'll call this peer entity relationship, right? This is one of my patents, peer entity relationship. And in the physical world, we call it a peer data set connector, right? So these are tables, so we'll call it peer data set connector. It's an interesting relationship. It gives you unlimited plug and play connections. So I show it connecting 3 different data sets here, but you could connect 30 data sets, 300 data sets, 1,000, it doesn't matter. It's unique key to unique key, right, across tables. And that's what makes it plug and play, right? So it's not inheriting anything. We actually have the data already there. We just have to connect it. So it's connecting the dots. And this is where you're enforcing data integrity. Now, how do we enforce data integrity with these peer data set connectors? Everything is done from a single source. So all 3 of these tables are populated from a single source, which we'll call a data compatibility standard table, right? And the single source, of course, is the third party address validator. So they're doing all this for us, right? And then the interesting thing of this is these peer data set connectors form the threads of our data fabric, right? So this is what ties all these data systems together and forms this seamless data fabric. So it's a new kind of relationship, and it's got very interesting properties for joining across data sets. Uh, okay, so that's the data integrity part of this. Now, the next part is the modularization. So I put on the top of the screen, I left up
Question,
the important factor. Yes,
question, sorry.
yes,
Okay, can I throw a question because my audience
yes, fine, fine,
will be
fine.
asking this. So if you can kindly go back to the previous slide. So yeah, so this is to be, and previous to this one is as is, right?
Right, exactly.
Yeah, previous one is as is, and this is to be. Now the question
Yes.
comes, how you reach from as is to be. If you have incoming slides, I think I can wait, but I think that's a disconnect right now where this goes and connects.
Right. Well, that's the point. We take the data from here, the
Hmm.
original data, send it to our address validator. Our address validator standardizes it and sends it back to us, and we populate it into the new structure, and then make a relationship between the new structure and the old structure to say this is the standardized address for this
So,
non-standardized address.
so
So it's
what we
pretty
are,
straightforward.
yeah, so what we are saying here, just for the understanding of our audience, that we have lookup tables, kind of lookup tables behind it, and then your module comes, it refers to your, I would say, master or universal lookup tables, and which you have
The registry data,
your
yeah, we call it
registry,
a data registry.
yeah, registry, which you have, for example, the example of address is you must have filled that data registry from universal libraries. Somewhere you have brought that data.
It's yeah,
Correct?
the data comes from the U.S. United States Postal Service, right? Everybody
Ah,
uses that for yeah. So if you're in Google and you type in an address and it comes back and it shows you where it is on the map and all that, it's the
ah,
same thing,
so, so,
right? So
so,
we're
so,
using that
yeah.
capability.
So what you're saying is as is will go into the standard universal data set, which is your, and you have brought it from, for example, this is US. And if someone need this solution for Australia, let's say, let's refer Adam is here from Australia, then you
Mhm.
will work with registry or library from Australia, Postal Service XYZ, and you
Well,
put it, yeah.
the U.S. I think they track 200. Is it 280 countries? They have the addresses from all over
Oh,
the
okay, okay,
world.
good enough. So the
So,
idea,
like
yeah,
where you are, if you just type your address into Google, it'll show you on the map where you are,
yeah.
right?
So,
It
so
all goes into the
yeah.
U.S. Postal Service.
So what we are saying is you have a registry behind it, registry, or you can say repository, whatever. So as
Yes,
is will go into that, and to be will be created from that. Correct?
right. And then we create the structures, the standardized structures, which we sell, right? And then you put the data into there and you're all set.
Awesome, awesome. I think if
Okay.
anybody have any question, I can, there's a question here, is master data is the master lookup table? I think the answer is, this is not your master data solution, right? Master data is a different thing, right?
Well, this is, like I said, it's the context, right? The data set context, which is full of master data. I guess I should have explained that a little bit better. Well, we will do that on the modular part. But when I look at the data sets, the important part for interacting across data sets is this data set context, this outer shell of master data. So it's like you're slowly changing dimensions. If you can manage slowly changing dimensions in a data warehouse, you know what this is, right? So it's the same thing. It's dealing with all that.
Yeah.
Okay?
So we have questions are coming. I think let's park those questions. Let's finish your one and then go through those
Okay.
questions. Yeah. Yeah. Thanks, John
So
and
the next,
yeah.
yeah, the next part of this, of course, is the modular plug and play part, right? So I knew how to integrate or make multiple databases directly interoperable, but I only had a couple databases. There's millions of them out there.
Hmm.
So the question is, how do we show that this works for all the databases? So I wasn't interested in the bottom-up approach where we take, 5 or 10 databases and do a data integration. I'm interested in making 25 data sets interoperable or 100 or 500, that type of thing. So I took a top-down approach to this. And I had to use something called deductive reasoning, right, which is a scientific method that we use, but we needed a model for that. So my model is the data universe, right, the totality of metadata and data content, which supports all the mathematical consistency. In other words, I had to have this huge data universe where we can do slicing and dicing and roll ups and drill downs and aggregations and allocations and all the things that we do mathematically in databases, right? So this was the model. So it's the biggest data set, the biggest data model you've ever seen, right? It's what this model is. It's everything, right? So then you use a hypothesis or a null hypothesis, right? So the first question I asked was, is there a single data universe? That's a hypothesis, right? And the other part of it, the null hypothesis or the alternate, is that there's more than one data universe. Well, it turns out when we do our analysis, there's many data universes out there. In fact, every data model you make that's not standardized, it creates its own data universe. Every data set that you create that's not standardized is a different data universe. So when you think about what we're doing with ETL, we're taking multiple data universes and transforming data from one data universe to another, right? Which isn't what we really want. We want to have one data universe. So this approach unifies all that data into a single data universe. So that's our approach. Now, how do we do it? The next thing we had to find out is this data universe, is it infinite, right? Or is it finite? It turns out it's finite, which is a good thing because that means there's an outer boundary. So the problem was then to find the outer boundary of our data universe, which actually comes back to the experimental part where we find this data set context, the outer shell of master data. So if you look at a data set, you have the facts pretty much in the middle, the bullseye, right? The facts and the metrics and stuff. And then you have your sales orders and your purchase orders and things like that, your documentation of all this. That's the intermediate level. And the outer bound of all this is this master data, which is slowly changing, which is also a good thing. So we have our finite data universe. So that's what we were keying on, this outer bound. And when we do this in our data models and in our data sets, we form these anchor points where everything is anchored to relative to everything else, right? So if we have, like I said, if you have address and you have a standard address, that's an anchor point in your data universe. And anything that relates to that is anchored into this single data universe that we're trying to form. So the concept is we want a single data universe. We have the anchor points to do it. So we can standardize all this data and put it in the same data universe, which now makes it so that you can put as much into this universe as you want. You can put thousands of data sets into it and make it all work. The other thing I found out is actually when you look at the model of this, you realize there's no real data set silos, because even if you just look at time dimension, time is a continuum within the data universe, and an object, there's data that appears before other data and after other data, so it's all relative. So even just looking at time, you would realize that there's no real data set silos. And what's happening with our data modeling and our architecture is that we're making these siloed data sets because we don't understand how to relate the data sets to each other. So this is the solution to it. And in reality, in theory, we can make all data sets directly interoperable. So we're saying any data set that you have that you standardize, and it's standardized the same as everybody else's, you get the same data universe, right? So it's a way of bringing all the data together to form one single universe that you can query across. Now, the important part of this is the the scope of this data universe, or scope of this interoperability, depends on the scope of the standards. So we're going to talk about the standards in a minute. So this is a good place if you have any questions to go forward, and we'll
Yeah,
show you the modularity.
now I have a question, and I have a question from John. I think let's
Uh-huh.
let me ask this question. How do you deal with addresses breaks? Google make mistakes and has missing information.
Well, yeah, you're dependent on the registry, of course. So we haven't had that issue yet as far as having, but matching, sometimes you get a mismatch and things like that. But remember, we still have the original address. So we don't change it. So you can do a quality check on all this stuff and make sure it makes sense. In fact, that's recommended, right? So if you get an address that doesn't seem to match, you may have to work, through something else. But in general, it works for everything we've tried so far. So
So let me add here. I think John, if you are listening, I think your dog solution comes into picture here as well. That if the success rate and probability rate is not high, you can again go back and set it. I think John, it's a good question. So we have one more question, right? Asrul, I think he's from Malaysia, if I'm not wrong. He's
mhm.
asking that how much processing power needed to do this interoperability, because okay, let me add my question as well here. So when we talk about this data universe, this is a data model or set of lookup tables sitting behind somewhere, right? Now, obvious question is this sitting in your SaaS solution, in your cloud, in your VM, somewhere outside customer, or you will bring this whole piece of data in customer location and adding to that processing power as well?
Right. It stays. We don't make a copy of the database, right? We just use the address validators in this case. We're going to talk later about Dun and Bradstreet because we use Dun and Bradstreet for organization. So they keep the database. We just send them information, the address and the name of the organization. They send that back to us because they've set that up to be able to do that. And so you don't have to have the whole set there to start with. And then the other thing is you only do it once, right? So you get the address, you get the match. It's not like you're doing it constantly. It's a one-time bulk update, right?
Okay, okay. Then this
And then when you have the slowly changing part, that's when you have to do the one-offs, right?
ah then that brings another question. It means
Mm-hmm.
one example you have given is address, but for
Mm-hmm.
interoperability, there'll be n number of subject areas. Products is one, customer is another. There are many
Right,
other
right,
things.
right.
So what you are saying is you will have these kind of data universes sitting everywhere. And I think your product is your IP, I guess, that you go and connect to everywhere and make sure that you have accurate data as in to be in your system. Is my understanding correct?
Yes. Yeah,
Okay.
that sounds right. We'll talk about it a little more when we get to a data architecture, if we get that far, because this gives you a lot of options in data architecture. We'll talk about
Okay.
it.
Okay.
Data architecture is now different than what it was with disparate data.
Okay.
Okay, so let's look at this going forward. What do we do? So we take, this is our modularity again. So we take a disparate data set. It can be a first copy of the data set. It doesn't have to be, the source. It can be a copy of the source. It can be a copy of the source that's denormalized if we want to help with performance, things like that. So we take that and we add what we call our data compatibility standards to encapsulate the data source, right? And the reason we know, you talked about the domains. Okay, there's different master data domains. So when you have a master data domain in the source, that's the standard that you add to it, right? So that we now have a new outer context of the data set. And by doing that, simply it creates this analytics and AI ready modular plug and play data set. So again, it's modularized because of the standards that we add. It's analytics ready because the standards include a dimensionalized version, so you can do roll ups and drill downs and all that. It's AI ready because it forms a fabric. It interacts with the other data sets to form a fabric. The plug and play we talked about because of the relationship of the connectors, right? The peer data set connectors. So that's the concept. That's all that really needs to be done. There's no programming involved. This is really a design-based solution. You don't have a lot of well, you don't have any ETL, to tell you the truth. So, I mean, whatever it takes to get the data set prepared and then to add the standards. But once that's all done, the interactions between the data sets, there's no software necessary other than what the normal tools that you use. Okay, so first of all, it's non-invasive, so we don't touch the original data. We leave that unchanged. Everything is additive to this, so it's non-invasive to the data set and it's non-invasive to the existing architecture. So if you have applications sitting above this, it's fine. That all works, right? If you have ETL that work, you pull the ETL and that still works, right? We didn't change any of that. What we really added was master data commonality so we could make the joins. So the interesting thing of all this is the reason we can't join across data sets is because there's no commonality in the master data. There's nothing to join to. So all I did was add the data you need so that you have the ability to join across the data sets. Right?
So
So it's really it's a simple solution. Go ahead.
I have a question here
Yep.
because once you bring
Yeah.
this master data commonality added here, right? So I think you are
Mm-hmm.
referring towards standardizing the data rather than finding the golden record. Correct me if I'm wrong.
In this case, yes.
You are not
Yes.
finding the golden record, right?
Well, the golden record is part of the architecture we'll talk about because we want to have the golden record too,
Yes.
right? So the data fabric itself that's formed is a single source of the truth in a sense, but then we take it beyond that because there's actually some redundancy in the data compatibility standards because they're done multiple places. So the standards themselves don't contain business data. It contains ways of linking across data sets without really having business data in there. It's kind of interesting. The business data ends up in the golden record.
Yeah.
Okay, we'll
Yeah.
show you that in the architecture. Okay, so we're adding master data commonality, and then each data set becomes an integral component of your modular data fabric, right? So like I said, you can have this data fabric with 100 data sets that are modularized. You modularize a new one, you plug it in, it interfaces directly with these 100 data sets that already exist. So there's no software, it just, so it's very object oriented in that respect. And we'll show you some of that in a few minutes. And then the data fabrics are actually compatible. If organization A and organization B use the same data compatibility standards, then their data fabrics are also compatible. So if they want to share information or make information available to a partner, they can do that easily. So, okay.
I
So
think I
that's
think
the theory behind all this.
there's a question and very relevant on this screen. As we mentioned,
Okay.
slowly changing dimension as well. The question is this very much for data warehousing or this can be used for all OLTP system as well, like source operational systems?
It's for both. It's
It's
for
both.
both. Right. Because when we take the original copy of the data set, right, it forms the fabric because we enforce data integrity, but we also have the dimensions in the standards so that we can do roll-ups and drill downs. So it actually does everything. And the warehouse now is composed of multiple data sets that you can dynamically bring together. So your warehouse is a very dynamic warehouse, but we
Yeah.
can also instantiate one that's more permanent. Let's get on to the demonstration part of this. It'll help, I think, to understand it. So for our demonstration, we're going to take two companies that merged a while ago. So mergers and acquisitions are always tough to do for IT, right? So we took one entity cluster represents some of the financial data from our fictitious company called Honeywell, and we have another data group of data entities on that represent Novar. So what do we do with this? You can see they're disparate. There's no relationship between them, right? So there's no enforced integrity. So what do? We add our data compatibility standards. Now, in this case, we added our DCS location, which is our addresses. DCS stands for Data Compatibility Standard, by the way. So this is our location, our addresses. This is organization. So I mentioned earlier, Dun and Bradstreet, right? So we populate this with Dun and Bradstreet by taking information from down here. We added a third one here, which is our interface. So we want to make this non-invasive. So we're drawing the primary key of the business unit out into this and then making the relationships here instead of inheriting the foreign keys into this. So this is totally non-invasive, right? We also have another entity here, which I can't show because it's too big, but that's for calendar. So just imagine calendar being there as well. And that's what you'll see in the database. So what do? On the other side, we add the same standards, right? Make the relationship into that cluster. Now, because we have the same standards, we have our master data commonality. We bring in our peer entity relationships because this is a data model, which become peer data set connectors. So we have one for organization. We have one across the bottom here for location. We have another one for calendar. So we now have three different connection points between these data sets. So let's go to Cogenity. Let's see, this is going to take me a second. Now I think I have to do new share on this.
Yeah, I can see this pro screen. Yeah.
Okay, so now you should see the Cogenity. Cogenity is a
Yeah.
tool that goes across databases. You can see it or no?
Yeah, we can see this progeny project.
Okay, very good. Um, okay, so I mean, you could do this with SQL Server Management Studio or whatever, but this tool goes across different data sets. They have all these different connectors for the different kinds of data sets. You can see I'm currently connected to 1,071 databases in here. So we'll open this up. I only want to use 6 of these databases. So I use the filter button here and set up the filters, and now I'm only looking at our 6 databases for the demonstration. To show you, we have 3 production databases, 3 test databases. So here's a production database for database 3, which I showed the model for. Here's our DCS organization, location, calendar, right? And then the other 2 data entities that were in that cluster. So that's database 3. Here's database 2, right? And again, we have calendar, location, organization, and the other data sets that were, or the other database tables that were in the um, diagram. And then this is database 1. Now, database 1 is what we call our Data Compatibility Standards factory. This is where we built the standard. And we have a location here, for example. You can see we have country and county and things like that, cities. So those are the different levels of hierarchy that we had to break it into. We enforce referential integrity to make sure that all this makes sense, and then we denormalize it into our standard, which is what we have here with where's location, DCS location. And just to point out, we also have here our standard industry code. So we're going to use this to show you inheritance. What happens with inheritance in this setup, whenever we make it available to the fabric, it's inherited by the other data systems. So if I have 50 data systems with organization, right, and I want to add standard industry code, today I would have to add it to each one of those 50 sets separately and manage it separately, right? So in this case, we added to one data set, which inherited throughout the fabric. So now I have one place to manage our interaction between standard industry codes and organizations, and it's applied to the rest of the data set, which is really cool when you think about it. Whole different approach than what's done today. Okay, so to show you, we have a query here. Let's see, we got, just to show you, this is database 1, database 2, and database 3, right? So we're going to do a query across our 3 databases, and we do execute. Oh, I guess I shouldn't highlight that. And we get our, so today you'd have to build a data warehouse first, right? Because there's no master data commonality. We added the master data commonality. It sets up the relationships. We can query across data sets. It's as simple as that. Now, in each one of these queries, you'll see that there has to be at least one of these DCS tables. In this case, it's DCS calendar, right? To show you how the anchor points work, I took DCS calendar from database 1, but I'm going to take it from database 2, run the same query, and it should work, right? So now I have database 2 connected to database 1, and then I add database 3, we can run it again, right? So I have 3 databases connected by this one table. Okay, let's take a look at our test environment. Our test environment has that as well. I can run that, and again, we get that. So that's, 4 databases, but we go to test environment 2, right? It's the same database table in the different environments. So I have here 6 different databases tied together to this one anchor point of our data universe, right? So the whole concept is we brought these 3 databases into the same data universe, or these 6 databases into the same data universe, and I can query across them now just as easy as could be. And to show you, we have more here. We have here's a different query, and again, this is a little bit more complex, but it goes across the same databases, it involves the same 3 databases, and I, of course, can change again if I wanted to change this and show how it links. And again, another one. This one's, I moved the whole thing. This one's a union, but it all works the same. So It's just a matter of writing queries across data sets. Now, of course, we wouldn't really normally do this, all right? We would use a tool if we can. So I'm going to show you Power BI. Do you have any questions on this particular part of how this works?
Actually, there are a couple of questions, but I will park it for last 10 minutes. We have 8 minutes more before we open
Oh,
the floor for others.
okay.
So I'm planning last 10 minutes for people, but if you want to drag it, it's fine. But we have a time check of 18 minutes, by the way.
Okay. So let me get to Power BI.
Hey, someone want to see the schema one more time. If you can jump back for a second. I think Adam, we can refer to the recording later. Yeah, go ahead, Bob.
So you want to see this?
Yeah, I think yes.
Oh, wait a
Adam,
minute. I got to do new share
yeah, we can see that.
and share.
We can see that. Yeah,
Okay, this is what you want to see, the schema?
I got it. Yeah, he got it. Yeah, yeah,
Okay. Now we have to go to, we have to get over to Power BI. Oh, actually, we could do I'm in the right place. Let me go, I don't want that. Okay, here we go. We'll get back into the schema so I can uh, explain this. Okay, so share, and we're good. Okay, so the next slide, if I can get focus here, is this. Okay, so this is Power BI. Most people are familiar with, most popular BI tool out there, I guess, but in case you're not, each one of these visuals is related to one of our data compatibility standards, right? So here's our DCS calendar. So this is our representation of revenue by year, by month, quarter, whatever. The next one is organization, right? So this is our organization slice. And these two down here are location, right? So this is our location information. And then this last one, which is kind of interesting, is our golden records area, because you had asked about the golden record area. Now, this is the shared database. Remember, I said database one has standard industry codes in it. So these standard industry codes are going to drive um, some of our queries across the data set, and you'll see how that all works. Okay, so now I'm going to get to um, the actual Power BI, if we can find it. Down here, and I'll share this. Okay, now you should see Power BI.
yeah,
Yes?
yeah,
Okay, have to get this out of the way. Okay, so here I have what we showed you on the slides. But what I did is to show you the additivity. This tab shows us database one and database two combined. This tab shows us database one and three combined. And then the last one shows us all three databases combined. So just to show you the additivity of all this, that this really works, you'll notice that Company A has $677 million of revenue, showing three standard industry codes and four locations. All right. When I take Company B, we have 625 million. We have one standard industry code. We have, what do I have here? One, two, three different locations. When we add them all together, we get our 1.3 billion, right? We get our four standard industry codes, and we get all seven of the locations. So just to show you how it adds up and it all works.
yeah,
If we look at energy services, for example, well, that was quick. Okay, so this is our slice of energy services. Now, again, this is driven from database one into database two and three to get the results. So it's querying across databases. I can also go back, and then we can do aerospace sector, for example, or chemical sector. I guess Nah, let me do it this way. All right. All right, let's go back in here
Yeah.
and we can do, let's just do organization. So we can do,
Yeah, I think if you need to select two, you have to use command,
I,
okay, or
I had
control.
to, I had to, I had to reset that.
Okay.
So we go back and do it here. Gee, it was so fast a minute ago. Now it's taking time.
That's Murphy's law, you know.
Yeah. That's the way it
No,
is.
it's going good. It's going
So
good. Yeah.
yeah, so here we go. So that's organization. Um, and again, don't want to reset for me. This is interesting because we haven't used this tool. Okay, so here's calendar. So we're showing the last quarter, and with nuclear, right? Because I didn't reset the whole thing. But anyway, that's how it works. You know, guys all know how Power BI works. But this shows you what you can do as far as bringing the data sets together and making them interoperable within the tool set that you already own. So I'm just trying to show how it really works. The next thing I wanted to show is the data architecture. Maybe we don't have a lot of time for that though. Um, so Alt Tab, let's see, new share. Okay, do you see we're back at the screen?
Yeah. Yeah.
Okay, so here's the architecture screen. I'm hoping you see this.
Yes,
So
yes.
just to show you, we have Cogenity, which we use as our tool for data management underneath the fabric, right? We have the data sources, the data consumption layer over here. There's actually only two parts to the data architecture, the Data Compatibility Standards Factory, which we talked about, and then the modular data fabric. But just to rush through this, we have three different types of data registries that we use. Here's our external registry. So we talked about location and we talked about organization associated with it. And you could do products. So if you're a retailer and you have, the barcodes and stuff, that's all external. Internal registry. So we may want to do something for chart of accounts because that's pretty much um, specific for the company and organization, and then calendar, which is a defined set. So that's pretty straightforward. Um, then the modular part, there's three parts of the modular fabric. Here's your modular data foundation, which is where we take the source data sets and make copies and modularize them, right? So that's done here. Then we also have a data content management system, so we can modularize the unstructured data sets. So we can now combine unstructured and structured data sets together, which is very useful for AI, obviously. The golden record area we talked about. So we have a golden record area here. So we take the enterprise view of data, or it can be from an external registry. I know we bought different information from Dun and Bradstreet about organizations, when we did this. And then the other area, which is now an area for our sandbox, so we can do um, materialized views from these original data sets, and we can build up other data sets from it. So let's say you have these three data sets that you use all the time together. We would actually materialize them into another data set and make it a single data set for performance purposes. Or if you wanted to do a study on churn to figure out why people are leaving, you would take subsets of the data, move it into churn, use that for machine learning, and then of course could apply this back to the original data sets, the scores, to get you the ability, the propensity for an organization to change and leave your brand, for example. So that's very quick go through this.
This
You'll
is
find
perfect.
that
Yeah.
this data architecture, since we don't have We don't have data set silos. We have data sets that work together. You have a lot more opportunity in here to build something of significance to the organization that you couldn't do in the old architecture. So that's where we're headed.
Yeah, no worries. No, I think this is perfect. And I love this demo. I think let's give 8 odd minutes to the audience as well. I can see Ahmed has raised. So let me unmute Ahmed. Yeah, Ahmed, I think you can unmute yourself. Yeah, you can.
Hey, hello. Thank you for the presentation. Really like the project and what have been shared. I was having a couple of points. My first question was, how did you link the initial data set to the Duns and Bradstreet one? Which was like, was that a deterministic link? Like, did you have in the database already some unique ID that allowed you to do it, or did you had to manage a search one by one? And second was to get maybe a sense of the volume of this, so to know if it is something that you see as scalable, like would it work for if we were having, I don't know, maybe 500K organizations. I think like Dun& and Bradstreet
Yeah,
will make a huge, yeah.
we've actually done this for a Fortune 100 company
Okay.
already.
Okay.
But
Okay.
it was, and we did use Dun& Bradstreet for that particular one. So the first question dealt with, what was the first question again?
Sorry, was how did you link the initial
Oh, the linking.
database
Okay.
with the Duns database? Like, was it a
Yeah.
search record by record?
No, we did a bulk load, but what we had to do before we applied DUNS, we had to do the addresses first. So we standardized the addresses, right? Because DUNS information depended on addresses. So we standardized the addresses through our address validator, and then we use those standardized addresses with the company information, the company name, basically. So it's name and address you submit to DUNS, and they give you all this information, about what the company is and the hierarchy of the company. So we did an enrichment, which was really great for these guys because they didn't understand how these companies are connected to other companies, right? Because there's subsidiaries and there's different
Yes.
locations for the same company and all that. So it's a very complex thing dealing with the customers. And this was institutional customers. So it was,
Yes.
well, you know that because it's organization. So hope that answered your question.
Yeah. Yeah. Thank you. Thank you.
Yeah.
Okay.
So it was a bulk load. It was a bulk load once we got there.
Yeah. Okay. Next is John. Now, John, are you able to unmute yourself? Okay. Yeah,
Yeah,
you are.
I think I've just figured out Zoom. I use it so rarely, I've forgotten how to run it. So, all good. Yeah, thanks, Bob. It's a really great presentation. I guess it's just coming back to my earlier point, or a question really. You obviously shown, this is architecture. I've seen architectures like this before. I've actually done a few myself, so I understand it quite well. You talked about this being on the sort of operational transactional side of the fence, but obviously there's a whole life cycle and sort of two-wayness of things, especially if you're talking about golden record. And I see obviously you've got the data coming in from the data sources one way. How does that kind of work? So obviously with a golden record of a customer, there's changes through different systems and they kind of flow in and out of them. So can you just talk a little bit about how your solution sort of covers that if it does? If it doesn't, then no problem.
Yeah. I mean, basically, we take each system and modularize it, right? Now we can query across systems. So you can actually build and materialize a customer record as a 360, right? But the thing is, now you have to have a steward going in there, or you can get information from the third party, right? So we bought information from Dun & Bradstreet, for example, to add to the customer information. So that one's sort of hand built, but it's done by SQL because all these things are compatible now, right? So anything that you build becomes an enhancement to the fabric, right? So everything's about the data fabric now. It's not about a single system. Did that help you?
It's more kind of you've got for the data sources on the left, they all need the golden record. So how does data get back into them if you make changes in the
Oh no,
fabric?
you don't need to put it back because it's part of the record. It's part of the fabric. right? So you just query it. You don't have to put it back in. Now, if you want to, you can if the storage, but it's there anyway, right? So there's no real reason to feed it back in unless the system owner wants to update it and make his data that he has and overwrite it. I mean, he can do that. But a lot of people don't want to overwrite the operational data anyway. So they just query across the data sets, just like it's part of the data set, right?
Right, thank
You
you.
get what I'm saying?
Yeah,
You sound
I think it's
disappointed.
just that if you're doing golden record, then every system like Salesforce on the left-hand side needs to have that record of that golden record. If someone changes it, it needs to propagate throughout the whole organization. Otherwise, it's not golden record, right?
Right, right. Well, this has multiple contexts, though. We've had problems because we had Dun and Bradstreet information, and we fed it back to the owners of the original source data sets, but they didn't want to change their source data. So we just made it available for them so they could query against the golden record, or they could query against their own version of the truth, if you wish.
Let me add something here. Maybe John, this is going a good discussion, right? I think John, there will be a 2B data model as well. 2B tables. Correct me if I'm wrong, Bob, right? Because there is as is and there is 2B. So as is will go via the API outside and bring the right record as a 2B table. Now that 2B table, I agree with John that there has to be some synchronization that across the systems, if you have like three tables you showed Bob for the addresses, right? If those three tables are sitting in three different databases, different
Right.
systems, and now John question is if one changes, then how it will go update
But
into three? I think we have to create some synchronization or some those kind of parameters as well, correct?
yeah, so my point is we tried that and people didn't want to overwrite their original data, right? They had access to the enterprise view anyway because it's directly related. So they could show the data in the standard form or they could show it in their local form,
Yeah.
because they have local reports and all that stuff that come out of the system. So it was up to them if they wanted to change it, but we never had anyone that changed it that I know of, right? They just referenced it. They just referenced it where it now is, if they
Yeah,
wanted to see it, because it's just another table. It's just another join.
yeah. I think let's take last question from Tariq. We are already not on. Tariq, go ahead. You can unmute yourself and you can ask your question.
Yes, sir. Thank you, sir, for giving me this kind of opportunity. I'm thankful to you. And my question is to Sir Bob Mack that the addresses that had been mentioned here, are these like IP addresses? Are these different from those addresses? This is my question, sir.
The addresses that we used were postal addresses, residents, locations where these companies sit.
So it's
We
actual
didn't
addresses.
we didn't have a standard for IP. We didn't have a standard. We never had to do that yet for IP addresses. I don't know what I would use for IP addresses as a standard offhand.
Now, okay,
So we might
Thank
have
you.
to have, you would have an internal registry, I guess, in that case.
okay. I think we are good. We are 1 minute on top. I think it was a great session, Bob, and I really love this whole product. I think there are a lot of participants today, 23 plus, I think, when it went to max. And by the way, I can see people are from Australia, from UK, from France, from US, from Malaysia, from Dubai. So all those people are there. So it was a good session, I would
Yeah.
say. And anything last you want to for the closing of the
Well,
session, Bob?
if people want to talk to us about proof of concepts, projects, or doing an assessment for their data sets so we can see what it's going to cost, what it's going to take for the standards, we're happy to do all that. And if people want to come back and ask more questions about the presentation, or if they want to personalize the presentation, we're happy to do all that. We're
Yeah,
in the building phase at this point, right? We're trying to build the business a lot larger than what it currently is. So,
Yeah. Since I've
and I
seen,
thank you for the opportunity also, right? And I
no,
thank people for joining us.
no, pleasure. As I like this demo, I'm going to talk to few customers, Bob, and hopefully we can plan our dedicated demo with customers and do some kind of POCs or pilots or maybe MVP one, and let's see how it
Yeah.
goes. But the solution is awesome. Of course, once we go in, customizations are always there, and
Mhm.
we have to go and try it out. Thank you, Bob. Again, pleasure. We are already 2 minutes on top. I think people are leaving because all are on job right now. Thank you, Bob. Take care.
Thank you. Take care.
Bye bye. Pleasure.
Goodbye.